Alright, today we're doing special cases. However, you don't have to actually learn the special cases in order to factor. We're going to factor the normal way. But I want to go ahead and give you the names of the special cases. The names are perfect square trinomial. And what that means is that you've got a term here that can be squared and a term here that can be squared. And what you can end up doing when you're done factoring it is you can write it as a quantity squared. And so we're going to see that on all these problems here first of all today. The next one, or the problems that we're going to work out, what you're going to see is that they're just like the problems that you have been doing. We're still going to create the two parentheses. And the difference is, if you notice that you have perfect squares, meaning that something times itself gives you that, so this one would be 4 times 4, chances are that is going to be the solution to the problem. And so we're going to have x times x. And instead of going through all the factors of 16, I'm going to jump right to it and try 4 times 4 because I know today that that's what's going to be. Notice that that's what the perfect square trinomial says. It's 2 of the a and the b multiplied together. Well, the a and the b multiplied together are 4x, and it's 2 of those, so it'd be an 8x. We want a positive 8. So this is a 4x, and this is a 4x. And the way I get the positive 8 is by putting 2 positives in there. A way we can write this differently is just x plus 4 quantity squared. The second example, we have two parentheses again. We have an n and an n. That gives me n times n. Since I noticed that this is a perfect square, I'm going to say what's the square root of 64, and it's 8. So I'll put 8 and 8 in there. I have an 8n and an 8n. I need a negative 16, so I need a negative on both of those. So it'll be a minus 8 and a minus 8. Again, when you get the same quantity, you can write them as one quantity squared. Continuing on, we're going to keep looking at some more examples. I think that you'll find these to be pretty simple. If you'll look back at the last example you just did, that one was n squared minus 16n plus 64, and this one is n squared plus 16n plus 64. So the only thing different is the sign right here. So I'm going to factor this into n times n. That will give me my n squared. Again, 64 is a perfect square, meaning 8 times 8 is 64. So I'm going to try 8 times 8. This does give me 8n and 8n. 8n and 8n is a positive 16, so I just need to put 2 positives in there. I can write this as one quantity squared. Next example, I'm just going to keep going through these pretty quickly. I think most of you will like these. Like I said, if m times m gives you your m squared, what times what gives you 9? Well, 3 times 3, or 1 times 9, but since it's a perfect square, I'm going to try the 3 times 3. I get 3 and 3, 3m and 3m. I need a negative 6, so I need a negative and a negative, so I put 2 minuses. That gives me m minus 3 squared. I have a few more of these. Next one has x times x is x squared. 144. You may not recognize the perfect square, but 12 times 12 is 144, so I'll put 12 here and 12 there. So I get 12x and a 12x. 12 plus 12 is 24. Again, you can write this as x plus 12 quantity squared. On my next problem, I have a perfect square here. It's 10 times 10, and I need to put an m with each one of those because I need an m squared. And here's a perfect square of 7, so I'm going to put 7 times 7. Check this, gives me 70m and 70m. I need a negative 140, so I put a minus and a minus. This is 10m minus 7 squared. I have two more. Let's see if I can squeeze these in here. I've got a perfect square here, so it'll be 3x times 3x. Perfect square here, 4 times 4. This gives me 12 plus 12, so I have positives inside. Last one, I have 8m to the second times 8m to the second, n times n. I need a negative 16, so these would both need to be negative. I should have written these as quantity squares as well.